Hello students, in today's video lesson, I'll be completing exercise 8.2. Let us see how to solve question number 5 from this exercise. In parallelogram ABCD, it is mentioned that E and F are the midpoints of AB and CD. So I've put a black dot out here, a point out here indicating E is a midpoint of AB and F is a midpoint of CD. You have to prove that segment AF and segment EC, they trisect DB. The meaning of trisecting DB is you have to prove that this DB is divided into 3 equal parts. That is BQ equal to QP equal to DB. So write down what is given and what you need to prove. Let us see how to prove it. Now, it is mentioned that ABCD is a parallelogram. That means the opposite sides are congruent and parallel. That is, AB is congruent to CD and AB is parallel to DC. What we are going to do out here is, we will prove AECF is a parallelogram. Now, how do we go about doing it? Please look at the solution. E is a midpoint of AB. That means AE is equal to EB, right? F is a midpoint of CD, so DF is equal to CF. Now, AB is congruent to CD. So half of AB will be congruent to half of CD. I have not mentioned it out here. Therefore, what is half of AB? AE. Therefore, AE congruent to half of CD is FC. So I've proved AE congruent to FC. Similarly, why would AE be parallel to CF? AB is parallel to CD. Therefore, part of AB, that is AE, will be parallel to part of DC, that is CF. So we have proved that in quadrilateral AECF, AE is parallel to CF and AE is equal to CF. Since one pair of opposite side is congruent and the same opposite side is parallel, the quadrilateral will become a parallelogram. There are some steps that I have not mentioned it out here, but I have just proved it. Okay, so listen to what I have said. Why would AE be congruent to CF? I've already mentioned it out. Now, first step is over, proving AECF is a parallelogram. Now, after having proved that, therefore, AF is parallel to CE because they are the other opposite side of the parallelogram, right? And AF is parallel to CE because they are the other opposite side of the parallelogram. If AF is parallel to CE, then why would we get PF parallel to CQ and AP parallel to EQ? Now, AP and PF, they are the part of AF, right? Therefore, PF will be parallel to CQ. And AP, which is a part of AF, will be parallel to EQ. So you could write the reason as paths of parallel lines are parallel. So after having proved AECF is a parallelogram, you make a note that AF is parallel to EC. And if AF is parallel to EC, their parts will be parallel to each other. Therefore, AP parallel to EQ and PF parallel to QC. Okay, now F is a midpoint of DC. You're already aware. Let us take triangle DQC. In this triangle DQC, F is the midpoint of CD and we have proved PF parallel to QC. And if PF is parallel to QC and F is a midpoint of CD, then P becomes the midpoint of DQ. Look at the solution. We will take triangle DQC. F is a midpoint of CD is already given. And we have proved PF is parallel to QC. Therefore, P becomes the midpoint of DQ because of converse of midpoint theorem. Right? Now, similarly, we will take another triangle and the other triangle is APB. Now, in this triangle APB, you already know that E is the midpoint of AB. It is given. We just proved EQ is parallel to AP, okay, and therefore Q will become the midpoint of which segment? Yes, it will become the midpoint of seg PB, okay. Now, let us take this. P is a midpoint of DQ and Q is a midpoint of BP. So from that, this is what you get as statement 1 and statement 2. And if you combine these two, you get PQ equal to DP equal to QB. So from 1 and 2, we have proved that AF and EC, they trisect segment DB. Hence, proved. Now, this is question number 7. They have mentioned that in triangle ABC, which is right angled at C, M is the midpoint of seg AB, and it is also given that MD is parallel to BC. Look at the indications. Now, there are 3 things that you need to prove in this. That is, D is the midpoint of AC. Now, in order to prove D is the midpoint of AC, okay, we take this complete triangle ACB. I've already mentioned out here what is given and what you need to prove. So let us first prove D is the midpoint of AC. Now, M is the midpoint of AB. It is already given. MD is parallel to BC. It is given. Therefore, D becomes the midpoint of AC because of converse of midpoint theorem. So the first part is already proved. You have to prove MD perpendicular to AC. So take 2 parallel lines in this. MD is parallel to BC and AC is the transversal. MDC plus BCD, that is these two, they are interior angles and this is already 90. So this angle MDC will also be 90 degrees. And if angle MDC is 90, that means we have proved MD is perpendicular to AC. Now this is the last part. You have to prove CM equal to AM equal to half of AB. So again, these indications are the ones that we have already proved. We proved AD congruent to CD. In the previous slide, we proved MD is perpendicular to AC, so I put the perpendicular sign out here, right? And we also know that M is the midpoint of AB. Now we have to prove that CM is equal to AM and both of them are half of AB. So what I have done is I have joined C and M. Okay. Now we will take 2 triangles in this. That is triangle AMD and triangle CMD. Now on the basis of the indication, let us prove the 2 triangles congruent. So AD is congruent to CD. So AD is congruent to this segment CD because we've already proved that D is a midpoint. Then look at this angle and this angle out here. That is angle ADM is equal to angle CDM equal to 90, right? Now we have already proved MD is perpendicular to A. And then DM is a common side for both the triangles, DM equal to DM. Therefore, triangle AMD is congruent to triangle CMD by RHS or SAS congruence rule. By SAS congruence rule. Because this is side, angle, side. Since the hypotenuse is not shown congruent, it cannot be RHS. Now, after writing down the CPCT, the next step is, therefore, AM, okay, is equal to CM, which is a part of CPCT. But you know that AM is half of AB because M is the midpoint of AB, right? Now from 1 and 2, now let's compare these two statements. AM is half of AB, but what is AM equal to? AM equal to CM. So instead of AM, I can write CM. So CM equal to AM equal to half of AB. So this was question number 7 from exercise 8.2. There are 3 parts to it. I have proved all the 3. In the next video lesson, I will be starting with revision of all the chapters that you have for the second semester exam. Students, I want you to make a note of these 2 proofs in your geometry notebook. Until then, goodbye and take care.